Okay, here we go. We've got this differentiation problem, an IB high level A and I question. From the following diagram shows a graph of the function f of x equals ax cubed plus bx squared plus cx plus d between minus 2 and 2. And here's our picture. Okay, so we're going to state whether the following function is increasing or decreasing at x equals minus 1, 0, and 1. So at minus 1, we can see that it is decreasing. X equals 0. Here we can see that it's increasing. And at x equals 1, we can see it's past the maximum point, so therefore it is decreasing. So that's part A. Part B, write down the value of d. Now d is the constant here on the end of the function. So if we have x equals 0, this bit's 0, this bit's 0, and this bit's 0, so f of x just equals d. So our function will equal d when x equals 0, so we get minus 1. So d equals minus 1. Part C. We know the values a and b are such that we've got a minus x cubed plus x squared over 2. And the point minus 1 lies on the graph, find the value of c. So if we put that minus 1 into here, the y value is minus 1 equals, if you put minus 1 into x cubed, you get minus 1 cubed, which is minus 1, and it's minus that, so it's just 1. Minus 1 squared is also 1 over 2, so we're going to plus a half. And then we've got minus 1 times c, so it's minus c. And we know that d is minus 1, so just put a minus 1 in here. So we can quickly cancel that minus 1 and that minus 1 out. And then we take c to the other side, and we get c equals 3 over 2. Now we're going to use a graphic display to find the coordinates of the local maximum m. So I'm going to go to menu 5. And you can see I've put the function in already. Go to draw. And what we ought to do is check our view window. My minimum value of x is minus 2, my maximum value of x is 2. So long as I've got those right, it will find the maximum value, but it's also given me the y values to look at between 6 and minus 4, so I put those in. And we have our function drawn between minus 2 and 2. And we want to find the coordinates of this maximum here. So we're going to press graph solve, find the max, and it gives us that the max is at 0.8, x equals 0.893. So let's put d in. So our coordinates are 0.893 to 3 significant figures, and y is 0.0261 to 3SF. Part E, find f dash of x. So we want to differentiate this. So we're going to do E, and we're going to do f dash of x will equal. So the x cubed will go to minus 3x squared, take 1 off the times by the power, take 1 off the power, plus times by the power, we're going to get 2 times a half, so we get x, and then we're going to get the plus the value of c. Once x is differentiated, we get 3 over 2 for the derivative of that. Calculate f dash of 0. Well, all we need to do is put 0 into this. So we've got f dash of 0. That's going to equal 0 plus 0 plus 3 over 2. So the answer is 3 over 2. Part 2. Find the equation for the tangent at the point 0 minus 1. Well, let's go to sketch on our calculator, go to tangent, and put x equals 0 in just to be sure. And we've got the derivative. But if you press execute again, it gives you the equation of the tangent. But you must make sure for this to work that your calculator, the derivative mode is on. Otherwise, this won't work. So let's just put that in. And we get y equals 3 over 2x minus 1. Or you might prefer 1.5x minus 1. Both are equally good. So for part 3, write down the gradient to the normal. Well, the gradient to normal is just minus 1 over the gradient to the tangent. So the gradient of the normal is equal to minus 1 divided by 3 over 2, which gives us minus 2/3. Part G. Use a graphical display calculator to find the x-coordinates where f of x equals minus x. So let's go in. We've got our function for f of x. If we put another function, y equals minus x, and press execute, if we draw that, where they cross must be where this function equals minus x. And we can just go graph solve, find the intersection, and I get our first one of minus 1.54. Or we get to the next one, just here, 0.393, and then we'll get our last one in the in our domain of 1.65 to 3 significant figures. 2, 3, S, F. And there we go. That's our final answer to this question.